So in the previous videos, we have learned that sound is a vibration and how does it go from one place to the other with the help of molecules of that medium. So see guys, there are three mediums, solid, liquid and gas. All three of them have molecules, hence sound can easily travel in solid, liquid and gases like we saw in the previous video. Now what happens in the case of vacuum? See guys, vacuum means empty space. No air, no molecules. So because there are no molecules in vacuum, hence there is nothing to carry the sound. Therefore, sound cannot travel through vacuum. Is it clear guys? So now in this video, we'll basically read about this concept. So let's begin. The word vacuum means empty space. Even air is not present in vacuum. Thus, when there is no air in something, we say there is vacuum. So how exactly do we create vacuum? For example, take a glass jar over here. Initially air is there, simply suck out all the air. So see, a vacuum can be created in a glass jar by removing all the air from it with the help of a suction pump called vacuum pump. So simply suck out all the air. What remains behind is vacuum. So in vacuum, no sound can travel. Why? Because there are no molecules. So see guys, vacuum or space means no matter. No matter means no molecules. Hence sound cannot travel. So remember, a material medium like solid, liquid or gas is necessary for the transmission of sound. Sound cannot travel through vacuum. So let me show you an activity to confirm this fact. What we do is we take a glass jar and keep an electric bell inside. Now when the bell rings, we can easily hear the sound. Is it clear? Now what we're going to do is we're going to suck out all the air from this glass jar. So when you suck out all the air from the glass jar, what is created inside? Vacuum, that is no air. Now even though the bell is ringing, we cannot hear the sound. I repeat, initially when air was there, we could hear the sound. Now when there is vacuum, we cannot hear the sound. So this shows that sound cannot travel through vacuum. So what is the logic behind it? See guys, in both the cases, the bell is vibrating, hence sound is being produced. In this case, because air is there, hence the molecules of air are carrying the sound from here to our ear. Is this clear? But over here, there are no molecules, hence there is nothing to carry the sound from here to our ear. So because there are no molecules in vacuum, hence sound cannot be carried. Remember, sound is being produced, but it cannot travel. Why? There are no molecules. That is the concept. So let's read about it. A ringing electric bell is placed inside a tight glass jar containing air as shown over here. We can hear the sound of ringing bell clearly. Thus, when air is present in the glass jar, sound can travel through it and reach our ears. So here, when the bell is ringing, because air is present, we can hear the sound. Now guys, what happens when you take out all the air? Sound goes. The glass jar containing ringing bell is placed over the plate of a vacuum pump over here. Air is gradually removed from the glass jar by switching on the vacuum pump. As more and more air is removed from the glass jar, the sound of the ringing bell becomes fainter and fainter. So lesser the air over here, lesser the sound you'll hear. Is it clear? And once all the air has been sucked out, you'll not hear anything. And when all the air is removed from the glass jar, no sound can be heard at all, though we can still see the clapper striking. So see guys, the vibration is happening, sound is being produced, but we cannot hear it. Why? There are no molecules to carry the sound. Thus, when vacuum is created in the glass jar, then the sound of ringing bell placed inside it cannot be heard. Is it clear? Next, what do? This shows that sound cannot travel through vacuum and reach our ears. Next, what we do is we once again put in air. Once you put in air, again you can hear the sound. If air is now put back into the glass jar, then the sound of the ringing bell can be heard again. This shows that air is necessary for sound to travel from the ringing bell to our ears. So if the activity is clear, now let's go through the explanation. We can explain the above observation as follows. When clapper hits the bell vibrates and makes sound. Now, the vibrating bell makes the nearby air molecules to vibrate back and forth. So whenever an object is vibrating, it will make the molecules of the medium also to vibrate. These vibrating air molecules make the next layer of air molecules to vibrate and so on. So first this bell will vibrate, it will make these molecules vibrate, they'll make the next layer of molecules vibrate. Like this, the vibrations are carried from the bell into our ears. Is it clear? In this way, ultimately all the air molecules around the ringing bell start vibrating back and forth. When these vibrating air molecules fall on our ears, we can hear the sound of ringing bell. So when the vibration comes to our ears, that's when we hear the sound. If, however, there is no air between the ringing bell and the ear, then the vibrations cannot reach our ears and hence we cannot hear the sound. So when there is vacuum, there are no molecules. So who will carry the sound? No one is there, right? Hence we cannot hear the sound. So when there is vacuum in glass jar, there are no air molecules to carry sound, vibration, hence you cannot hear. So whenever you create vacuum, guys, because there are no molecules over here, hence sound cannot be carried. That is why we cannot hear the sound which is produced in vacuum. So remember, guys, for sound to travel, it needs a material medium, that is solid, liquid or gas. Why? Because only those medium have molecules in them. Why can't sound be heard in vacuum? Because there are no molecules in vacuum, hence there is no one to carry the sound. Sound is being produced but is not being carried. Why? No molecules. Hence sound cannot travel through vacuum. So I hope this concept and this activity is clear.